For the final project of deep reinforcement class, I am doing reinforcement learning for quadruped locomotion for unitary go-to in a Genesis simulation platform. And the method I am using is PPO-based actor critic, which is widely used in robotics for learning locomotion. In actor critic method, the value estimation is given by a critic network, and which gives the direction of improvement of the actor network, and the actor gives the outputs, 12 motor outputs here, and we take those 12 motor outputs, run the simulation again, generate data, and then feed it to the the value estimation network, and then estimation network gives the improvement to the actor, and then again we run the simulation. So this is the loop, how it works. For getting any improvement or any improvement in the actor, we take a certain number of steps, and for each step we run like 4096 parallel simulations. And once the data is generated, the training runs through 5 epochs in 4 mini batches, and after 5 epochs there will be an update in the actor network. The weights of the actor network will get updated. So our policy network expects 45 inputs. Those are the speed, joint position, joint speed, and the IMU information, that is the gravity vector, how is it oriented. And the whole simulation is running at 50 hertz, and the policy gives 12 joint position offsets as the output, and this is like the whole setup, like what is the expected input and output for the policy. So in the next slide we will see the first policy that we train. The first policy is the crouch. So when I started training this policy, initially it was using a gravity hack where it just fell into the ground to crouch, because I was giving a reward that you have to go z is equals to this 20 centimeter or 15 centimeters. But then I started giving negative reward for like downward velocity, but there was issues with like convergence, conflicting like goals. Then when I terminated the episodes which were having more z velocity, more than 0.7 centimeters, and then it converged into a good solution where it was crouching with a controlled behavior, unless it was trying to fall directly. So here we can see in the video that now it is able to go to a crouch position in a more controlled environment. And then I trained a jump policy, so in which I give a apex height, a reward for impulse, and also orientation, negative rewards for orientation and shake. So you can see like that also worked. And we got a walk policy from Genesis directly. The idea from these slides are how to transfer the policies to a real world setup, like sim to real. So for that, I added on the basic walk policy, I added domain randomization along friction surfaces and sensor noise. And when I added this, training was becoming difficult, so I had to use curriculum training where I increased the difficulty slowly. I also learned the stiffness of legs separately from the 12 outputs that we were already learning. And also I trained like omnidirectional, and I gave the critic a privileged information which was not originally in the setup for Genesis. So this was provided later in the code. So you can see like I then stress tested each simulation. This is like testing the simulation with different condition, like this is low friction. And then training it with, and then testing it with like high observation noise and latency to see the effects so that I can incorporate those in the simulation. And once it was trained, then you can see that it was able to run a walk comfortably in the simulation environment in all directions. So this is going backward. So the base policy was just moving forward. So I trained it in all direction with domain randomization and sensor noise input. So you can see a bit of recovery there also. So it is able to do some recoveries. And then I trained a stair climb where I gave a reward for a forward movement, like how much. So speed is not most important here. The forward progress is improvement, and height information I gave it to the critic directly from the simulation. So these were the changes that I changed to make it walk up the stairs. So you will see, and this is like a blind policy. The actor has no information about like the height of the stairs, so it cannot see the stairs. So you can see it is just like using the proprioceptive information to walk up the stairs. So these were the policies that I trained on Unitree Go 2. Yeah, thanks.